Welcome to a rainy Jodrell Bank Observatory in Cheshire on the day we discovered that we are only one of the 17 billion Earth-like planets in our Milky Way galaxy, which is in itself one of 350 billion galaxies in the observable universe.
But of all those, we'll be focusing much closer to home. We're going to take you on a journey to the surface of Mars to join one of the biggest quests in all of science, the hunt for life.
I'm Brian Cox, he's Dara O'Brien. We may be insignificant,
And wet,
but this is Stargazing Live.
Yes, welcome to a refreshingly damp night here in Cheshire. So come with us inside, into the control room of Jodrell Bank. Jodrell Bank is a jewel in the crown of British astronomy. From this site, scientists tracked Sputnik. They also performed the early detection of the first extragalactic radio signals and were instrumental in the discovery of pulsar, which we've spoken of before, dead stars that are the size of a city but weigh as much as the sun.
Yes, 2012 was a huge year for astronomy. We had the transit of Venus, the Messenger probe discovered water ice on Mercury, and also we celebrated the lives of three inspirational men, Neil Armstrong, Sir Patrick Moore, and also Sir Bernard Lovell, who built this incredible structure behind us, the Lovell Telescope. Now, Tim O'Brien is here, as always, the Associate Director of Jodrell Bank. So, Tim, in some ways a sad year for Jodrell, but in other ways a great year. I noticed new buildings.
Yeah, I think every time you come we have a new building, I think. So this is actually the global design headquarters for a brand new radio telescope that we're building now called the Square Kilometre Array.
Yeah, and the question, which isn't as silly as it sounds, is how big is that?
Yeah, I mean, the square kilometre bit is basically the sort of overall area of this telescope.
It's a dish like that, but
it's actually about 220 times the area of that dish, but,
Right.
but it's not sort of 1 kilometre across. It's actually thousands of individual receivers spread over hundreds or even thousands of
Yes,
kilometres.
it's South Africa, Australia, isn't
It's
it?
going to be built in Africa and Australia, yeah.
Wow, and this is the base for the British base, the design base is here.
So the international global design headquarters is here in a building just at the site here.
So many exciting things are happening at the moment. Now, what we want you to do is to settle in and prepare to journey with us to the stars. Here's what we've got coming up this series.
We'll be voyaging through space and time to explore some of the biggest questions in science. We'll be investigating the entire history of the universe, the formation of the solar system, and the origin of life itself.
We'll be looking at our own crowded corner of the cosmos, from man-made space junk to the comets and asteroids that could be heading our way.
We're live from NASA this year, birthplace of scores of space probes that are currently scattered across the solar system. We'll watch the next space missions being prepared, and we'll be communicating with the Curiosity rover, which is exploring Mars as we speak.
Closer to home, we're building our own version of one of the most important telescopes in the history of astronomy.
Plus, we'll find out how the invention of photography in the 19th century helped us to plot our position in the universe.
And as ever on Stargazing, we'll be telling you what to look out for in the skies above your head. Now, we don't want you to be passive consumers of this. Your participation is a massive part of the show. If you have a question for Brian here, then email it to us at stargazing@bbc.co.uk or tweet us using our account @BBC Stargazing. We also want to see your best astro photographs. Find out how to get them to us at the website, which is bbc.co.uk/stargazing, where you'll also be able to join in our live web chat, Talk Stargazing, where the deputy project scientist from NASA's Curiosity mission is standing by to take your questions.
Now, last year, you, the viewers at home, discovered a brand new candidate planet, Threppleton Holmes B, far outside the solar system. Amazing achievement, and so we thought we'd ask you once again for your help. This time, though, we're going to search a lot closer to home on the surface of Mars.
Yes, we'll be asking you to join in with a mass participation experiment to explore a totally uncharted area of the red planet, and all from the safety of your own armchair. Dr. Chris Linton will be here with the details of how you can take part a little later on.
And, as always, to tell us what's visible tonight in the cloudy and rainy skies above the UK, Mark Thompson is standing by outside in a muddy field. How's it looking out there, Mark?
Thanks, guys. Yes, I'm here with the hardy souls of the Liverpool Astronomical Society. How you doing, guys? Pretty optimistic. Now, it has been, as you can see, a cloudy, wet day, but the rain has stopped finally, so we do remain hopeful, don't we? Oh, yeah. That it is going to clear up tonight, so we'll see how it goes. Now, if the skies have been clear where you are, then unfortunately you've missed your chance to see Mars tonight, but it is visible for a short period at this time of year. You can see it just after sunset, about 10 degrees above the southwestern horizon in the constellation of Capricornus. But I'm afraid you're going to have to be quick, because by the end of the month it will disappear from view, and you'll have to wait until June to try and get a glimpse of it. So if you want to see it and don't want to miss it, you're going to have to get out there pretty soon. Now, if you're luckier than us and the skies are clear, then there's plenty still to see tonight. In the southeastern part of the sky, we've got Taurus rising up in the sky with a beautiful Hyades cluster and Jupiter shining bright just above it. So come back to us later in the show and see how we're getting on.
Okay, on the day that David Bowie released his first single for 11 years, watch the class of this link. Tonight, we are going to be asking...
Is there life on Mars?
quality television there.
Hello, ladies and gentlemen. Welcome to The One Show. I shouldn't have said that, Joe. In August, NASA landed this 900-kilogram, 2-metre-tall rover on the surface of Mars. And when I said this, it didn't work. This would have been a picture of Curiosity, which is the heaviest and biggest thing that man has ever landed on another planet. Its mission is to help answer some of the biggest questions in science. Has Mars ever had an environment that was able to support life?
Now, to give us an exclusive insight into Curiosity rover, Liz Bonin has travelled to NASA's Mission Control.
Welcome to NASA's Jet Propulsion Laboratory. Ever since the first American space mission in 1958 with Explorer 1, JPL has sent out over 100 spacecraft throughout our solar system. And this is mission control for its latest explorer, the Mars Curiosity rover. These are the engineers that monitor her every move and get the very first glimpse of all the valuable data she's sending back. Now, tonight, I'm going to be meeting the team that put Curiosity on Mars. We're going to find out what she's taught us so far about the red planet, and I'll be meeting her twin right here at JPL.
So we're very excited to be coming live from NASA tonight, and we think NASA are just as excited because a load of their staff members are currently watching it on their lunch break. So a big good afternoon to NASA. We'll hopefully get a wave off them once yeah, there we go. Fantastic. Lovely stuff. This kind of makes me more scared.
You always wanted to do that, haven't you? Good afternoon, NASA!
Yeah, it's a gig I've always wanted to play. What do you do for a living? Oh, you work in NASA. Good for you. Okay. Now, but they're literally all over Mars at the moment, like whatever, which is the topic we have tonight.
Yeah. So I think, first of all, a few facts about Mars.
Yes, Mars, in some ways our closest neighbour, between it and Venus, depending on the orbits. The last of the rocky planets before we get to the gas giants. And in some ways, this may be judgmental, but its best days are behind it. It was very volcanic for a while. Its volcanoes are the highest in the solar system. It has riverbeds, so it must have had water at some stage. And it had an atmosphere, and now it's lost it. It had a magnetic poles as well, and it's lost them as well.
Yeah.
So in many ways, its best days. But also very interesting for amateur astronomers because you can actually see the surface of it, which you can't say for Venus.
Well, I think it is. We've got an image here that we took last March, actually, when Mars was in opposition, which means when it was at the closest point in its orbit to Earth. Now, we used a 14-inch reflector for this, which is a big telescope, but it's still an amateur telescope. And you can see there, you can obviously see it's a planet, it's the red planet. You can see some detail at the pole, I think, actually, and beginning to see some surface features. So it is a planet that an amateur can observe, sketch, and see things on the surface with a relatively small telescope. Now, our special guest tonight is a keen amateur astronomer, also a professional astronomer in some ways, Dr. Brian May. Brian, thanks for joining us.
Nice to Dr. May, how are you?
Very good. Thank you.
Welcome to Jodrell Bank.
Thank you.
When was the last time you were in Jodrell Bank?
Last time I was here was 1968, when, as a new graduate physicist, I came here for a job, and Bernard Lovell interviewed me and offered me the job. And perhaps to my shame, I didn't take the job. I went back to Imperial College, where I've been researching anyway, and that's the sort of crossroads of my life.
And then you went to a phase,
And then other things happened, something happened musically, and I went away for a while.
You got that out of your
just a little
system.
while.
And did that, by the way, did the band all happen midway through the PhD? Did you ditch the PhD and that's the...
The PhD kind of got tired. I sort of got to the point where I knew that I couldn't get it to the point where I needed it to be, and music just called me and pulled me and pulled me.
Well,
Did that happen to you, Brian?
Well, it did, yes, but in reverse. Make us. That's you, isn't it? Back in 1970, 71.
Yeah, about 1970 in Tenerife with my coelostat, very close to the large volcano there.
And I know, obviously, that you went back, you got your PhD, you're also a keen amateur observer. Mars, the planets. I mean, I know you're a particular fan of gazing at the planets.
I love it, yeah. Mars is difficult, I think. I mean, I wouldn't make out that it's too easy, because you've got to have patience. It looks like a little red blob, and you've got to have patience, and eventually you might just see, the polar ice caps, which is a thrill, But if you go to, Saturn, then it's going to be a big wow straight away.
From London,
Yeah,
I do it in London. I mean, I have a telescope in the country, which just has all the sort of fancy go-to stuff, but I much prefer my little telescope on my roof in town.
So people shouldn't be scared of the noise, the light pollution in London or
pollution, actually, yeah, people laugh at me and say you won't see anything because of light pollution, but it's not true. It doesn't actually matter. If you're looking at planets, and you can see from sunset to sunrise, you can see stuff fine in London.
Okay. Well, our knowledge of Mars has been revolutionised in the last 50 years, thanks to the extraordinary work of scientists at places like NASA.
Yeah, in that time, they've sent 15 missions to the Red Planet, and it's completely transformed what we know about the landscape and conditions there. So let's take a quick look at what they've managed to achieve in that time. In 1964, we got close to the Red Planet for the very first time. NASA's Mariner 4 probe sent back pictures of a cratered surface, inspiring a generation of Martian explorers to go back and find out more. In 1971, Mariner 9 became the very first spacecraft to go into orbit around another planet, sending back far more detailed images that revealed Mars's enormous volcanoes. And by the middle of that decade, NASA's Viking landers had actually touched down on the planet's surface. Their cameras beamed back images of a rocky and apparently lifeless desert. 20 years later, the NASA Pathfinder mission returned to the surface with a rover, Sojourner, a mobile laboratory that drilled into the rocks to learn the secrets of Mars's past. Meanwhile, in the skies above, a new generation of NASA orbiters captured detailed bird's-eye views of the entire surface. And in 2004, the European Space Agency's Mars Express photographed the planet in 3D, giving us a stunning new perspective on Martian landscapes. In the same year, 2 new NASA rovers travelled for miles across the surface, exploring cliffs, sand dunes and craters during their epic journey of discovery. Spirit kept going for 6 years, while Opportunity is still on the move to this day. Nearly 50 years of exploration has told us more about Mars than we could have ever dreamt. And with the Curiosity rover, the stage is now set for a new era of Martian discovery. Now, let me show you that picture I wanted to show you of the Curiosity rover on Mars earlier, because it is spectacular. This is a self-portrait. Curiosity landed in the Gale crater. Landing site was chosen because this is a place where we are pretty sure that water existed at some point in the past. And it's a lot of noise on Twitter about this picture, actually, because people say...
People get very, very suspicious about this kind of stuff. Got very suspicious about this because it's a self-portrait of a freestanding rover.
Who took the picture? And I thought, you know, to prove that NASA are actually on Mars, I thought I'd show you a picture from Viking, which landed there back in the 1970s. This is the picture. This proves that NASA did land on Mars, and there was no funny business going on. That's one of my heroes, by the way, the great Carl Sagan.
But Curiosity has a much more profound mission than just exploring the landscape of the planet. Its goal is to search for evidence that Mars was habitable in the past, for any sign of the presence of the core building blocks that need to be present for life to develop and thrive.
Now, to tell us all about the mission and how they actually managed to get that enormous thing there in the first place, here is Liz, live from NASA.
Thanks very much, Brian. This is the very room where NASA scientists controlled the landing of the rover onto the surface of Mars. Now, obviously, it's very calm right now, but on the 6th of August last year, it was a very different place.
Touchdown confirmed. We're safe on Mars.
Now, one of the very excited people you saw there is, of course, Adam Stelzner, the man in charge of landing the rover. Thanks for joining us, Adam. Great to see you.
Thanks for having me.
Now, you will never forget that day. Is that safe to say?
Absolutely. We'll remember it forever. Best day ever.
Best day ever. When it comes to the previous rovers, they were sort of bounced onto the surface of Mars with big airbags, to put it very crudely. But then when you think about something like Curiosity, your team had to come up with a much more audacious plan to land the thing, right? Talk me through this animation.
Sure. We're starting on a parachute here,
Yeah.
and then we let go of the parachute and onto rockets. We've done that before. But we hadn't done this next step. Because she was so big, the team had to invent a new way of landing her, lowering her on cables beneath the descent stage and landing her gently on her wheels.
It is a thing of beauty. Every time I see this, I still cannot believe what you guys achieved. To make matters worse, you also had to deal with something called the 7 minutes of terror.
Yeah.
What were they?
Well, it takes 7 minutes to get from the top of the atmosphere down to the surface safely.
Okay.
And during that time, we are all, everybody in this room, everyone on Earth, spectators, waiting to see if Curiosity successfully steers her way through the atmosphere and makes it safe to the surface.
Terrifying, absolutely terrifying. And, you know, with something as challenging as this, and with all the options you might have had in your head, and you came up with this, did you ever, you know, at one point say, this is not going to work, I'm having second thoughts?
Every day through
Seriously?
the whole process, you're wondering about it, worrying about it. And there's a lot of other people who are wondering if this is really the right thing.
Sure.
In fact, all the way up to the head of NASA, the administrator, we had to convince him it was the right thing. He said it looked crazy, but he thought it might just be the right kind of crazy.
Beautiful. Adam, it really doesn't do it justice to say this to you, but well done. And thank you so much for joining us.
Thanks for having me.
Now, another thing that NASA is very good at is maximizing its chances of success for every single mission that it does. So when it comes to Curiosity, it did think of everything. It even made an exact copy of it here at JPL to put through its paces. So obviously, I had to go and check it out. The job for the Earthbound twin is to practice moving in this replica of the Martian landscape. It may not look much, but these variations of sand and stone are the best guess at what Curiosity might encounter. It's so exciting to see it in action, it really is.
Yeah, it's a really cool robot, right? You're standing right up close to this thing that's taller than you are. And even though it's moving very slowly, it's kind of scary. Remember, it has a laser it could, shoot you with. So
that's not even funny.
So yeah, we're going to stay back here where it, where it can't shoot us.
Scott Maxwell drives the real Curiosity. His job is to avoid steering a multi-billion-dollar vehicle into a Martian ditch. So the meticulously planned rehearsals with this twin are crucial. Right now, it's trying to navigate what it thinks are the sloping sides of a Martian valley. With the rotating camera, it takes 3 stills, which help it plot the safest route and avoid toppling over. Then it powers forward a few centimeters and begins the process again. I love the way the wheels move. So this is going this way.
Yep.
So clever. The record of the painstaking rehearsal is then sent up to the twin on Mars. How fast can the rover go?
It goes, I think it's something like 0.1 of a mile per hour. 2.5 meters per minute is the number that's in my head. The reason for that is the rover mass is about a ton, and it only has enough energy to run 2 ordinary kitchen light bulbs. So you think about trying to drive something around that's about the mass of a ton with enough power to run 2 ordinary light bulbs. And as you can imagine, it doesn't go very fast.
And why so little energy?
We've got a chunk of radioactive plutonium, and we've got a device that turns the heat that's given off by that radioactive rock into electricity, and that's about 110 watts. It's part of a complex trade-off to get basically as much power as we could in the rover without being too heavy.
Fair enough. Meanwhile, about 140 million miles away on Mars, communication isn't good enough for video. So NASA has created simulations to help visualize the rover's journey. As the Martian dawn breaks, Curiosity awaits instructions.
We email the rover a package of stuff that says, here's your to-do list for the day. And then we go home and go to sleep. The rover spends this entire day carrying out those commands. And at the end of the day, it emails us back a package saying, okay, here's what I did. And on a good day, those 2 packages look the same. The things you wanted the rover to do look like what the rover actually did.
But on a bad day?
On a bad day, they're different. So far, we have never, harmed the rover. We've never driven the rover over a cliff or anything like that. She's packed full of science instruments. Curiosity can look at rocks up to 12 meters away and zap them with a laser and look at the vapor, the spectrum, the light spectra of the vapor, and determine properties and mineral content of the rocks to understand whether she wants to drive over there and start to investigate more completely. We've got an ability to drill into rocky material and take out powdered samples, sort them by grain size, and then distribute them to science instruments in the body of the rover.
So have you had a moment yet where you've gone, oh, we should have put this on it as well? Or are you, so far so good?
So far so good. Curiosity is our next big step, blowing out of the water anything we've done on Mars today.
Can you believe they've allowed me in here? This is the dark room, the operations center for NASA's Deep Space Network, and they communicate with everything from telescopes to probes to orbiters in here. And the man in charge of pouring through all the data that Curiosity is sending back via this room is John Grotzinger, Chief Scientist with the mission. John, thank you so much for joining us. It's such a privilege to be in here. Actually, just checking, it's 21 minutes past 8 in the UK, 21 minutes past 12 here in LA. What time is it on Mars right now, and what is the rover doing?
Right now, it's just slightly after 2 o'clock in the morning, local mean solar time on Mars,
Right.
and Curiosity has just finished processing some of its data and beginning to send some back to Earth.
Now, in the 152 sols or Martian days it's been working, it's sent back already tens of thousands of images, some of which are extremely exciting to you. Can you talk me through this one?
Yeah, they are spectacular. This is one of my favorite. It's the foothills of Mount Sharp, little hills here that are sort of hundreds of meters high, that add up to a mountain that's almost 5 kilometers high. And what we see here are layers. This mountain is made out of layers, and that allows us geologists to read it like a book. And we start down with earliest chapters, turn the pages, and understand the early environmental history of Mars.
You're taking a trip back in geological time. It's wonderful. This other image is even more interesting for obvious reasons. Okay, so this is Mars on the left, Earth on the right. Talk me through what we're looking at here.
Yeah, now this is something we found literally where we landed.
Okay.
The rover touched down. And what you see here is sort of Mars for the common man. You don't need a higher degree to understand this kind of science. What we have are rounded pebbles. And here's a stream bed from Earth, some gravel that accumulates. And here it is on Mars. And the difference is that this one comes from 300 million miles away and 3 billion years back in time. We know we had an ancient flowing river.
So there's evidence of water, and you're also looking for evidence through the sedimentary layers as well, right?
Yeah, and so those layers, there's what tell us when we see the involvement of water about ancient habitable environments. These could be the kind of places where microorganisms might have lived.
That's just wonderful. Can't wait to see what other images she sends back in the next 2 years of her mission. Thank you so much, John.
Thanks.
Coming up next, I will be checking out Curiosity's twin here at JPL and also finding out about the future of NASA's Mars mission. See you very soon.
Thank you very much, Liz. Now, John mentioned there water being a key component of this search for evidence of past life. So if you're looking for life, why water and nothing else?
Well, we've got a little experiment here to show the basic physics behind it. So if you start rubbing.
I got a rubber sticker and I've got just an ordinary fleece.
What Dara's going to do is he's going to charge that rod up. And I'm going to fill this cup with water. And well, I'm not going to tell you what you should see. I'm going to
Well, hopefully it should be very evident. Hopefully you should see... No, hang on. Right, carry on talking, please.
That's one more.
Yeah.
Water is there. Can you see that? So You see the water is bending slightly, has to be said, but bending towards the charged rod. That's because of the structure of the water molecules themselves. They're what's called polar molecules. So there it goes.
There we go.
So water is responding. There's a force actually on the water due to the fact there's an electric field from this rod. Water molecules. Imagine my fist.
Right.
Just imagine. That's an oxygen molecule. Water's H2O. So you're two hydrogens.
Okay, I'll be hydrogen.
Oxygen wants electrons. It's an element that really wants to drag electrons around it if it can. So it does. It drags the electrons off the hydrogens. That's why there are bonds there. But it leaves these two protons, which are positively charged, relatively exposed. Relatively exposed. So the net result is you get a positive charge up here, a negative charge down here, and that's why water molecules respond in an electric field.
In some ways, would it be like a bar magnet with a plus and minus end?
It's a bit like that, so you can see that it responds. But that has a very interesting effect when you look at the structure of the liquid. It looks simple, it's the simplest thing in the universe. But if you look at this picture, then that is a picture, a representation of what some of the water molecules do in a liquid. So not solid, it's not ice, it's a liquid. They clump up because the negative bits, the oxygens, can bond to the hydrogens from other water molecules.
Okay, Grant. So you can create this kind of lattice of H2O molecules linking with each other in a loose. And this isn't a solid. This isn't ice.
They look like ice, but they're passive structures that come and go in the liquid. They're called hydrogen bonds. Those things, and that has very important consequences. One is that water's like a scaffolding, as you can see there, and so biological molecules like proteins can be orientated in the right way by the water because of that complex structure of water. And the way that proteins and complex carbon molecules are aligned tells you how they react. It's key to our biochemistry. Also because of that polarity, water, they're small molecules, they can get inside other things. It's a superb solvent, one of the best solvents we know of. Also, because of those hydrogen bonds, it is liquid across a vast range of temperature. And if you look at hydrogen sulfide, which is the same structure as water, but with sulfur with hydrogen bonded to it, that boils at -60. So you wouldn't have hydrogen sulfide as a liquid on the surface of a planet like Earth. Water, of course, is liquid at these pressures between 0 and 100 Celsius.
Because of the polarity, which we demonstrated there, the fact that you can polarize these things, they loosely link together into a structure, a framework, a scaffold for life, and they're also liquid in a way that liquid at temperatures other liquids aren't.
Yes, and nothing hydrogen bonds like water. And so that's why most biologists, I think it's fair to say, would say that water is a prerequisite necessary for the existence of life.
So if you want to find life, you have to find liquid water. That's what we think at the moment. On Mars, there is no liquid water at the moment, but we know that it exists as ice at the poles and as permafrost underneath the ground.
Well, yeah, but what various NASA missions have discovered is evidence that liquid water used to flow on its surface. Now, if you take a look at an image like that is an image from orbit by Mars Global Surveyor taken in 2003. It's a river valley, it's a river delta, and it obviously looks like that. You can also, I just want to show you the polar caps. Mars' north polar cap, south polar cap. A proportion of that is certainly water ice.
So what happened to all that water? Earth is right next door, and we're covered in liquid water. So what makes the two planets so different?
Our next door neighbour is known as the Red Planet, a rocky, lifeless world covered in dust. But Mars hasn't always been a desert. Billions of years ago, we think that liquid water flowed here, perhaps even enough for a Martian ocean. So where did all the water go? When did Mars die? In the early solar system, debris came together to form the inner planets. So Mars and the Earth are made from the same material. At the heart of each is a metallic core, something that's key to the difference between the two planets today. In the Earth, the outer core is molten, and as it spins, an electric current is produced, generating a magnetic field that extends way out into space. And it's the effect of this magnetic field that could explain why we have water and Mars doesn't. When charged particles leave the sun, they head towards us as the solar wind, but our magnetic field deflects them, protecting our atmosphere. But the situation on Mars is very different. Being smaller, Mars had less heat to begin with, and it also lost it to space more quickly. Its molten outer core began to solidify, weakening its electrical currents. So by 3.5 billion years ago, Mars's magnetic field had almost completely shut down. Without its protection, the solar wind blasted much of the atmosphere into space, leaving it 100 times less dense than our own. And that had a devastating effect on Mars's water. On the Earth, we have ice at the poles, water vapour across our skies, and liquid water in the oceans. Water exists in 3 states, something that's possible because we have a thick atmosphere, thanks largely to the protection given by the magnetic field. But in today's thin and cold Martian atmosphere, while we find both ice and water vapour, there's barely any liquid water at all. And it's probably been that way ever since Mars lost its magnetic field. So the challenge now is to look for signs of liquid water in Mars's distant past, before it disappeared. Perhaps billions of years ago, life may have exploited a brief opportunity to flourish when the red planet was blue.
And a good parallel of what would happen to liquid water on the surface of Mars comes if you look at frozen carbon dioxide or dry ice here on Earth. I mean, that's the block of frozen dry ice there. But if you heat it up, it doesn't turn into liquid at all. It sublimates. It goes directly to vapor.
You're loving your demos, aren't you?
I love this.
It's not science club, this.
Yeah,
Anyway, well, the interesting thing, though, is that's how water would behave on Mars. Because the pressure's lower, the combination of pressure and temperature that tells you how a substance will behave. Now, we tend to think of Earth as unique because we have liquid water on the surface. You might think it's a rare commodity, but if you include ice and vapour, water is actually incredibly abundant throughout the universe, which might not be so surprising because oxygen is the third most abundant element, and hydrogen, of course, the most abundant element in the universe. Let's give you an example. Let's welcome back Tim O'Brien, the director here at Jodrell. Now, Tim, I want to start with a picture. This is a picture that'll be familiar to virtually every amateur astronomer, the Orion Nebula. Beautiful sight in with the naked eye in the winter sky. But you pointed one of the radio telescopes here at the Orion Nebula.
So we're actually pointing our second biggest telescope here. It's called the Mark II, right this minute at
there it is.
the Orion Nebula.
Now, does that cable go all the way out to the field somewhere else?
This cable travels right the way across our site, right to the top, the focus of that telescope. And what you're seeing here, right in the middle of this trace, this live signal, is radiation coming from water vapour molecules in clouds in the Orion Nebula, 1,300 light years
So
away.
what actually is this? It's obviously it's radio waves.
Yep.
Seen by the radio telescope.
Yep.
What are we actually looking at?
It's a thing called a maser, so it's a bit like a laser, except the M stands for microwave. It's in the microwave radio part of the spectrum. So it's spinning water molecules in space that are radiated, beaming these radio waves towards us, which is why it's so bright.
This is a signal of spinning water molecules in space. You are seeing to cloud
Live.
and
You know,
rain.
that is actually
I find
live,
that's wonderful. That's actually happening at the moment. FRC right now.
I'm just impressed that you get to see that amount of water vapour through the water vapour that we're all struggling
exactly. We've got
to
to see through our own atmosphere with all those rain clouds, and we can see this.
How much is there?
There's probably about 100 or so times the mass of the Sun
Right.
in the Orion Nebula.
Which sounds like a lot, but I just wanted to show this Chandra X-ray observatory image of a quasar, APM0, whatever it's called. This is I can't bother reading it. This is an artist's impression of what that looks like. Tim, very, very briefly, what are we looking at here?
So a quasar is a distant galaxy with a supermassive black hole at its heart, billions of times the mass of the Sun.
Yeah.
And this particular one is the most distant detection of water we've ever made in the universe.
Right.
It's probably about 35 billion times the mass of the Earth in terms of the amount of water.
So much distant also means presumably the earliest detection of water that we have.
It's so far away that the light from this thing's taken 12 billion years to reach us.
Yeah, which is fascinating because you think, oxygen, it must be produced in a generation of stars. So at least one generation of stars have lived and died to produce the oxygen to build the water in there. And how many trillion?
35 billion times the mass of the Earth, basically.
Okay, so water is everywhere in the universe. In fact, Earth isn't even the only place in the solar system where you can find liquid water. In fact, I'll go further. There might be more of water on the moons of other planets than there is here on our own planet. Liz is standing by with Linda Spilker from Cassini, the NASA mission which first discovered liquid water on Saturn's moons right now.
Thanks very much, Dara. Linda, thanks for joining us. You've been involved with the Cassini mission since 1988.
That's right.
And it has sent us back some spectacular images of Saturn's moons. Can you talk me through Enceladus? Because there are features on the surface that point to liquid water, is that right?
Right, these 5 bluish tiger stripes are cracks or fractures in the crust of Enceladus at the South Pole. And Cassini instruments have measured the temperature deep inside these cracks, and we find that it's warm enough to have liquid water underneath the tiger stripes. And this liquid water comes squirting out of jets from the tiger stripes, freezes when it goes into space, and forms this beautiful comet-like plume.
It's a stunning image. And when it comes to Titan, Saturn's most famous moon, this is a very recent image from Cassini.
Yes, yeah.
It's a river system flowing into an ocean. Now, this is liquid methane, which in itself is really interesting. And scientists are even talking about the possibility of methane-based life forms.
right.
But is there also evidence of liquid water on Titan?
There's evidence of liquid water on Titan, but not on its surface.
Okay.
It's too cold there. Titan is deformed by Saturn's gravity as it orbits around, squeezed in and out. And this amount of deformation is great enough that we know it can't be frozen solid. There has to be a liquid water ocean underneath Titan's icy crust.
Interesting. And you combine the evidence of liquid water with hydrocarbons. That is music to the ears of astrobiologists. It points to the possibility of life, doesn't it?
Oh, it's a fascinating possibility.
Excellent. Thank you so much, Linda. Coming up next from us at JPL, we'll be finding out about the future of Mars missions here at NASA. See you very soon.
Now, it's not just Titan. There's another candidate for liquid water in the solar system, and that's Jupiter's moon, Europa. Now, this is a picture of Europa taken by Galileo, which was in orbit in the Jovian system for a long time, back in the 1990s. What you're looking at there is a surface of water ice. We know that because of spectroscopy, so the way that the light interacts with the surface, with the ice. And you can also see there are a lot of cracks on the surface. And if we zoom in to another picture, again taken by Galileo, of those ridges on Europa, then what you're looking at there is ice sheets, but moving against each other. Over the years, Galileo saw those ridges shift. We also have pictures from Voyager, actually, back in the 70s of those ridges. That is very suggestive because it looks like it's the same way that water ice behaves in the Antarctic or the Arctic. So that, also the way that Europa interacts with Jupiter's magnetic field when it orbits around it, tells us there's an ocean beneath that ice. And the fascinating thing is that there's more water in the ocean of Europa than there is in all the oceans of the Earth combined.
So there's liquid water within that, but it's a long way away from the sun. So where is it going to get heat from?
It is, and it's from its orbit. The orbit's very elliptical. It's kept elliptical, actually, by its interaction with the other moons of Jupiter, the Jovian satellites, the Galilean satellites. Because it's elliptical, it comes close to Jupiter, further away. The moon gets stretched and squashed. That heats the interior of the moon up by friction, just like if you did it on a squash ball, and that's what melts the ice and gives us this tremendous ocean beneath the surface.
Now, if there are clear skies above where you are, then it'll be relatively easy to observe Europa and the other three largest moons of Jupiter after the show tonight. And brilliant, if you do get out there and observe them, you'll be following the footsteps of one of the greatest scientists of all time.
In 1610, Galileo Galilei became the first person to observe the 4 largest moons of Jupiter. He tracked their movement with a new invention, the telescope, and found they were orbiting around the gas giant. At the time, the widely accepted view was that all celestial bodies orbited the Earth, that we were at the centre of the universe. But Galileo's discovery shattered this belief. They're known today as the Galilean moons, and they're really easy to observe.
Anyone can get a glimpse of these distant worlds, and it won't break the bank. Even a simple pair of binoculars like these, or a small telescope, will reveal Jupiter's companions.
Finding Jupiter is really easy at the moment, as it's one of the brightest objects in the night sky. Simply look due south around 7 p.m. The moons can't be seen with the naked eye, but look through a decent pair of binoculars, and they are suddenly revealed. They are even more impressive through a telescope.
Each moon is a distinctive world, but even through a telescope, it's difficult to identify which is which.
This is because they are so far away that they appear small and faint, even through an eyepiece. The 4 moons have different orbits, so working out which one you're observing can be tricky. And you may not see all of them all of the time, as 1 or 2 may be behind Jupiter when you're looking. Fortunately, there are free reference charts online and affordable apps to help you identify them.
I'm lucky at the moment I can see all 4 Galilean moons. I'm using an app to help me identify which is which.
The moon I can see on the far left is Ganymede. It's the largest moon in the solar system, with a diameter greater than the planet Mercury. The tiny dot you can see to the immediate left of Jupiter is Io. It's the most volcanically active body in the solar system, covered in hundreds of sulfur-spewing volcanoes. To the right of Jupiter, the first moon I can see is Europa. This is the moon that scientists seeking life are most interested in. Images taken by the Galileo mission have shown us it's a frozen world encased in an icy crust that resembles the Arctic flows of Earth. And last but not least, we come to the outermost Galilean moon, Callisto. It's believed to have the oldest solid landscape in the solar system and bears the scars of 4 billion years of impacts. Thanks to their constant dance around Jupiter, observing the moons can be different every time.
It's a spectacular sight, and learning about these diverse worlds makes seeing them with your own eyes even more incredible. Now, it is possible to see all 4 of Jupiter's moons tonight, but unfortunately, I'm afraid it's still cloudy, so you can't see anything. But I've been joined by Brian May outside, and of course, Brian, the British weather, don't we just love it? And of course, it's rubbish for astronomy, isn't it, guys? Now, what is it that makes us keep coming back for more?
I guess we just love it. There is a passion for knowing what's out there, isn't there? And I think it's once it's kindled in us, it never goes away. Yeah, we still do it. We still do it in England, although we get a very low percentage of nights where we can actually see something. But when you do, boy, it's amazing.
It's really worth it, isn't it?
Yeah.
Well, we were lucky enough to capture some footage of the moons of Jupiter last night. We were doing some rehearsals, and it was clear for us during the rehearsals. You can see in this video footage the belt of Jupiter, and you can see the tiny speck of light just closest to the planet is the moon Europa. So we were very lucky to capture that last night. Now, of course, Brian, the planets are really quite spectacular for most of us. Do you remember the first time that you saw a planet? Remember how you felt?
Yeah, the first gasp was Saturn, and I still feel the same about it. The first time I saw it, I think I was a bit like Galileo, just like, my God, what is that? Because I wasn't educated. I was 10 years old and had a telescope which me and my dad built, and it looked like two little circles next to each other. And I went, that's weird. Why does it look like that? And then suddenly it dawned on me that you're looking at a planet with these wonderful rings around it, and it's just breathtaking. I mean, it is, isn't it? You never get over Saturn, do you? Just amazing, the most beautiful object in the
And it is quite amazing. Now, got a lot of keen amateur astronomers here. What's your top tip for these guys here tonight?
Well, I don't know about for you guys, but for people who are starting, you guys know what you're doing, but for people who are starting, I would say keep it simple. Get something which is rigid and doesn't flap about, but is simple. My favourite telescope is a Dobsonian, which is just something which you point and shoot. Basically, there's no gimmickry, there's no electronics or whatever.
Yeah, no.
You just know, you have a find on it and you go, I want to look at that, you go, and you're looking at it.
And that makes it so much easier, doesn't it?
I would say keep it simple, yeah. And learn your way around the universe.
And that's what makes it so much more enjoyable, isn't it? Now, of course, sorry, if you want to find out if it's clear tonight, we're unlucky here in Macclesfield tonight, but if you want to find out if it's clear where you are tonight after the show, then here's Nina Rich at the BBC Weather Centre.
Good luck.
Thank you very much, Mark. Good evening to you. Yes, unfortunately, you are stuck underneath the cloud there, but there are some places where we'll begin to see some breaks in the cloud. A weather front's been moving south across the country, taking with the rain as well. So parts of the Midlands, East Anglia and the South East corner, unfortunately, staying with the overcast skies throughout the night. However, to the north of that system, that's where we'll see some breaks in the cloud. Certainly Northern Ireland, North East England, Eastern Scotland. Here we'll see some clear skies through the night. But I think later on, the risk of perhaps some patchy mist and fog forming. So these certainly look like being our best spots for tonight across the northern half of the country. Thankfully, the moon isn't going to rise until later on in the night for those areas around about 6 o'clock in the morning. So again, Eastern Scotland, North East England and Northern Ireland, where you're most likely to see some breaks coming and going in that cloud through the night. Tomorrow night is looking a little bit cloudier, but Susan Powell will be here to give you those details. That's all from me.
Now, last year we teamed up with the Zooniverse Citizen Science Project and asked for your help to find a new planet outside of our solar system. It was a huge success, with over 130,000 of you taking part, resulting in the discovery of a brand new exoplanet, Treppleton Holmes B, by you, the viewers. Well, this year we want your help again.
So whilst Curiosity Rover is exploring the geology of Mars, we want your help to take part in our own exploration of the planet's surface. Here to explain is Dr. Chris Linter. So Chris, what are we going to do this year?
Well, Curiosity is doing a great job, but it's exploring one tiny piece of Mars, and that's like trying to understand Earth by sitting in Trafalgar Square for a few years. What we want to do is send the viewers out to the rest of Mars. And so we've taken images from a spacecraft called the Mars Reconnaissance Orbiter, and we put them up on a website, planet4.org.
Yeah.
And these are images that no one in history has ever seen at this level of detail. They've been sitting on a hard drive, and no one's looked at them. So here we have sand dunes. This is actually down in the Martian Antarctic, so near the South Pole.
What's the resolution here? What kind of
the small features, these small black things, are probably maybe 100 metres across, and the resolution, you can see things that are this sort of size.
It's quite
So
remarkable.
if your dining room table was on Mars, we'd see it in these images.
Yeah, and I think I can zoom in on one now, which is let's
Yeah, we'll zoom in
that
on these
one.
fans, because these are mysterious. We see them appear every spring, and then they disappear over the course of the summer.
Yeah.
And we don't quite know what causes them. We have our ideas, but these are one of the things that we want people to look for. So the site will teach you how to find these, and if you see them, you can mark them, and we'll try and understand
And
them.
you'll give people a patch of ground on Mars. And what kind of things should they be looking out for?
Well, these fans are very exciting. You see these spidery things as well. These are actually known as Martian spiders. This is what we think the fans are. If you imagine you were standing on a sand dune, you hear a rumbling underneath you, and suddenly this geyser erupts 200 metres into the air. That's what produces these fans, we think. We don't know, and we hope to test
But this could be very important, couldn't it? Because you could say this could be shown us that life, well, Mars is not a dead world.
That's right, this is something active that's happening on Mars. We think of Mars as a quiet place, but this is a dramatic and violent event, and it's telling us about the cycle that happens every year on Mars as it goes into spring.
Now, we know that you'll be back on Thursday with some of the most interesting results. So we want people to do this. We want you to go to the website. There's a full tutorial on there to find your patch of Mars. Go to bbc.co.uk/stargazing and click on the box that says Explore Mars.
Oh, it might be Threppleton Holmes C. Explosion on the surface of Mars. It's superb. Anyway, searching for life on Mars isn't a new idea, of course. Ever since we're able to observe the red planet with telescopes, scientists have been theorising about what Martian life would look like. So here's a quick look at how our theories have changed over the years.
The great astronomer William Herschel used his 20-foot telescope to produce some of the first detailed images of Mars. From observation after observation, Herschel faithfully recorded a surface with patches of light and dark areas. But then he went beyond simply observing. He speculated that those dark patches could be oceans. And if there were oceans, there could be life.
In 1783, Herschel published his findings on Mars in the Philosophical Transactions of the Royal Society. He says, and that planet has a considerable but moderate atmosphere, so that its inhabitants probably enjoy a situation in many respects similar to ours. So already he's making the assumption that people live there.
And that assumption that there are civilizations on Mars lived on for the best part of 100 years. Then in 1919 they made contact. The inventor of the wireless, Guglielmo Marconi, was experimenting with his radio at sea and thought that Mars was signaling to him.
In a way, I suppose this was the beginning of what we think of as modern radio astronomy, and it turned out that what he detected were not signals from Mars at all.
What Marconi actually picked up were natural signals generated in the atmosphere. But the world's imagination was caught, and science fiction authors eagerly turned the inhabitants of Mars from humans into monsters. The Martian was born, and they were all bent on interstellar domination.
This could be the beginning of the end for the human race.
Hollywood filmmakers chose to show Martians hidden inside Cyclops-like machines. Even NASA was at it.
On Mars, deadly ultraviolet radiation from the sun penetrates to the surface. Life forms on Mars may have silica shells to protect them against this radiation.
It was hoped that the speculation would end once and for all when NASA sent probes to Mars. As the images were beamed back, some still thought life would be found.
We've just had some amazing photographs sent back by the American probe to Mars, Mariner 6. You can see there some of the dark areas, which may be vegetation, and at the bottom you can see the white polar cap, which has always been thought to be due to some kind of icy or frosty deposit.
Alas, as we soon discovered, it turned out to be a dead planet, full of craters. So was that the end of the Martian? Well, no, actually. For the last 40 years, the search for life has continued. But the Martian just got smaller. Instead of little green men, we're now looking for little green microbes.
Well, joining us now is Dr. Lewis Dartnell from UCL, who is an astrobiologist. Yeah. To sum up, I suppose, what we've learned and speculation, I want to ask you the question, first of all. Speculate. What could we find on Mars?
I think that the best case, the best we can possibly hope for Mars, considering all we've seen about its environment and how this horrible collapse in the conditions billions of years ago, is for primitive bacterial life, the kind of extremophiles or extreme lovers that we find in harsh environments on Earth. And I've got a bit of show and tell here. This is a rock, this is a sandstone from Antarctica, from the dry valleys. So these very, very dry, cold environments, the most Mars-like environment on Earth. We use it to study our techniques of finding life. And if you actually turn over this rock and look on the inside, just beneath the surface, you see this thin smear of green. This is a community of life, of bacteria, that's colonized into the rock itself to protect themselves from the harsh, cold, dry environment outside and living inside it.
We could imagine organisms like that existing on Mars.
That's exactly what we're going to try and look for on Mars, yeah.
And the big question, I suppose, is would it be the same, in a sense, the same biochemistry, similar even all the way down to DNA, or would it be different? And if it were different, what would that suggest?
We think that the very fundamentals, so being water-based or carbon-based, they seem to be the best bets to look for. We'd be able to recognise that. But if we look at the kind of specifics of how those cells are built, what kind of organic molecules are put together to make them, perhaps something like DNA would be a bit too specific. There might be alternatives to DNA that would also be able to store the information, the operating manual for a cell, and pass on to the next generation.
All life on Earth is based on DNA.
Yeah,
would it be more or less exciting for you to find that the life on Mars was DNA than it being something completely different?
Really, really curious. So let's say that the probes that we're sending to Mars are successful. We find Martians, we find life on the surface of the red planet, and we take it apart, we look under the bonnet of these cells and see how they work, and we find that they're DNA-based and protein-based in the way that we are. That might mean that that's how life works. There's one way of making a living cell using those molecules. It might be that the reason Martian life is so similar to us is because it is us, and we are them, and we're the same thing, we come from the same
We got a question
origin.
on email from Chris Cahoon, who said, how do we know that we didn't come from Mars originally?
So that's the million-dollar question. If we find Martian life is very, very similar to us, it could be that life got started on Earth, because we have always been a wet, warm place, transferred over to Mars aboard a meteorite during this kind of spitting contest the inner planets had during the early solar system. Or it could be that life got started on Mars first, because it didn't have a big moon-forming impact. It got transferred over to Earth. So it might be we find Martians realising that we're here already.
We are
the Martians.
Wow. So what happens next in this search? What are the next steps for our exploration of Mars? Back to Liz at NASA Mission Control in Pasadena, California.
Thanks very much, Dara. Well, to answer that question, I am back with Curiosity's twin. You saw her earlier in the Mars yard, but this is another indoor facility where they can carry out slightly more sensitive tests. It's such a privilege to see her again. And we are joined by Dr. Fook Lee, who is the manager for all of the missions in NASA's Mars program. Thank you so much for joining us. We know you're a very busy man, Fook.
You're welcome.
Can I ask you first of all about the latest news that finally we're going to use the last tool in the rover's kit, the drill. Is that right?
That's absolutely right. The drill is at the end there, and we're going to use it to drill into rocks, turn them into powder, and deliver the powder into the analytical instrument that is in the front part of the rover. And yes, the scientists that spun rocks, they're really excited to test out this equipment.
Oh, can't wait to see what the data reveals. And when it comes to the future of Mars exploration, you have an orbiter mission coming up at the end of this year to investigate the thin atmosphere of Mars. You've also got another rover mission in 2020, but the one I'm really interested in is the one that speaks of returning samples back to Earth.
Yeah, many of the scientists believe that some of the most important problem that we have would involve returning a sample from Mars to Earth and use all the powerful instruments we have on Earth to analyze and address it. But of course, it's a much more ambitious thing because we have to take off from Mars and come back to Earth.
Extremely challenging, but ultimately do all these missions lead to one thing, and that is to put a man on Mars?
This is my personal opinion.
Okay.
We all have an innate spirit to go out and explore the unknown. In the past, we sail the oceans, we climb the mountains, we went to the South Pole and all that. And I believe that spirit is going to drive us also deeper into the solar system, beyond the Earth-Moon system. And one day, human footprint will be on Mars.
When, Fook?
I don't know. I hope one day soon.
Looking forward to that. Thank you so much for taking the time. We know you've got a lot on your plate right now.
You're welcome.
Thanks again. Well, that's it from us at JPL for today. But tomorrow, I'm going to find out more about NASA's Deep Space Network and all of its missions that are currently being undertaken here at NASA. And also, I'm going to find out about the biggest space telescope ever built, which might finally answer questions about our very origins. So make sure you join me then. Back to you guys. See you soon.
Thanks, Liz. See you tomorrow. Well, the next generation rover isn't from NASA. It's a joint European-Russian mission run by ESA, the European Space Agency. It's called ExoMars. It will be launched in 2018. And here it is. Here is the prototype of that rover. Well, with us is Abby Hutty from Astrium, who are responsible for the construction of this vehicle. Abby, give us an overview of this.
So this is Bridget. This is the very first prototype rover that we built to demonstrate our ability to build a Mars rover project. So it's different from Curiosity in that we're looking for life. We're not just looking for the conditions for life.
Yeah.
Can I say, we're about to start this just to get into this, but this actually is fully functional. I've been given the incredibly complex control device.
Bizarrely, you've let it so.
And also, these are presumably the similar kind of rocks you're going to use during the fake Mars landing of 2018, are they? Because they're very authentic.
But what's it? So I know we were talking earlier, and I can say it, you can't. You said in some ways, in many ways, this is better than Curiosity at some things.
Well, one of our big developments is the autonomy system, so autonomous navigation. We can actually give our rover a destination. It doesn't have to be even in the field of view of the rover, and it can look where it is, map in 3D, it can form an elevation map, decide what's a danger to it, what's a safe place to go, and plan a route towards that goal, drive itself completely unaided by us here on Earth.
And you said the key thing are two things. So there are life experiments, dedicated life search experiments.
Which I think is a good one. I'm just going to bring in Lewis as well, the astrobiologist. I think is very interested in this, and Brian May, who just I think wants to play with it as a toy.
This is what I've been waiting for.
And then there's the drill.
Back with that.
So the drill, we're going to get down 2 meters. Why would we want to do that?
Okay, so yeah, we've got this drill on the front of our rover, and where Curiosity is only managing to take a sample just from the surface, 5 centimetre long tool, we've actually got a 2 metre drill. We're going to drill subsurface, and 2 metres under the rock, it's going to be protected from the cosmic radiation environment. So if there is any life still on Mars, that's where we're likely to find it.
I must say, one word, is there life still on Mars?
Certainly.
I hope so. We're going to go through so we can discuss it at greater length. But first, we're going to go out and see how Mark is doing out in the field.
Well, all the astronomers have gone indoors now for the start of Back to Earth. I'm here on BBC Two in just a few minutes, but if you, like them, have been inspired to look up at the sky and learn about it, then there's loads of downloadable resources on our website. You can find out about stargazing live events up and down the country. Just go to bbc.co.uk/stargazing. And if you want a more detailed guide for what to look out for tonight, then you can stay tuned for my Starcast during Back to Earth, where you'll learn how to find some of the best objects visible tonight.
Thank you very much, Mark. If you're after hints and tips on getting started in astronomy, then you should check out this year's Star Guide, put together by the BBC and Open University. It'll help you get the most out of the night sky wherever you are in the UK. Pick up one from a BBC Stargazing event in your area, or if you want to order a copy, the details are on your screen right now. You enjoying that? That's fun. You just want to put stones in there and watch it climb over them. Sorry.
Try and stop me. Talk to you later in a minute. I know. But look, keep the questions coming in, unless there are conspiracy theories saying that we didn't land on Mars. In that case, keep your opinions to yourself. Anything else, we'd love to go to the website, Mars with Zunia.
We'll be back on in a second.
Yes, we'll be on in a bit. See you later.